For decades, we've been looking at the wrong targets. While the world's space agencies spend billions trying to find life in the red dust of Mars or the radiation-scorched moons of Jupiter, the most important mystery in our solar system has been sitting in total isolation, nearly 3 billion kilometers away. I'm talking about Uranus. Since 1986, when NASA's Voyager 2 flew past this pale blue sphere for just a few hours, we haven't been back. We have better photos of galaxies millions of light years away than we do of this giant in our own backyard. But as of 2026, the silence is finally about to break. China's National Space Administration has officially integrated a Uranus flyby into their upcoming Tianwen 4 mission. And they aren't doing it for pretty pictures. Here is the truth that most people miss. Uranus isn't just a gas giant, it's an ice giant. And according to data from the James Webb Telescope, this specific type of planet is the most common in the entire universe. By studying Uranus, China isn't just exploring a planet, they are trying to decode the blueprint of the galaxy. Whoever understands how these worlds work will essentially own the handbook for every exoplanet ever discovered. But there is a problem. Uranus is weird. It's the only planet in our system that rotates on its side, as if it was knocked over by a massive celestial collision in the past. It has a magnetic field that is literally broken, and temperatures so low they defy our current models of physics. While the West debates budgets and delays, China is moving toward a September 2029 launch, viewing Uranus as the ultimate scientific high ground. We are about to enter an era where the cold, dark edges of our system become the most important real estate in science. If you want to see how this mission will actually work and why Uranus is much more than just a ball of ice, make sure to hit that like button and subscribe to Exoplanet X. The real race for the outer planets is just getting started.
The most disturbing thing about Uranus isn't its distance or its cold, but its orientation. Every other planet in our solar system spins like a top, but Uranus rolls like a bowling ball. Its north pole points almost directly at the sun. For decades, astronomers have theorized that billions of years ago, a protoplanet twice the size of Earth slammed into Uranus, literally knocking it over and changing its fate forever. This collision wasn't just a random event, it's the reason Uranus is so incredibly weird today. Most gas giants radiate massive amounts of heat from their cores, but Uranus is cold. It's as if that ancient impact squeezed the internal heat out of the planet or created a thermal shield that traps the energy inside. China's interest in this mystery is purely strategic. By sending a probe to analyze the gravity and the chemical composition of the atmosphere, they hope to find the chemical fingerprints of that ancient impactor. If Chinese scientists can prove what hit Uranus, they will solve one of the greatest cold cases in the history of the solar system. But there's more. Uranus has a system of rings and 27 moons that shouldn't exist the way they do. Many of these moons are likely shrapnel from that ancient collision, frozen time capsules that hold the original materials from the birth of our solar system. The Tianwen 4 secondary probe will be looking for one thing in particular, the ionic water ocean. Deep beneath the clouds of Uranus, the pressure is so intense that water doesn't act like a liquid or a solid. It becomes a superionic conductor, a strange state of matter that could explain the planet's chaotic and tilted magnetic field. If China maps this field, they won't just understand Uranus, they will have a master key to understanding the magnetic shields of thousands of planets throughout the Milky Way.
Beyond the tilt and the cold, Uranus hides a phenomenon that sounds like pure science fiction, but it is a rigorous prediction of high-pressure physics. Beneath the thick layers of hydrogen and helium, the atmospheric pressure becomes so crushing that it breaks down methane molecules, squeezing the carbon into solid crystals. The result? It literally rains diamonds. These aren't tiny dust particles. Scientists believe these are massive, solid gemstones that sink through the mantle like sparkling hailstones. But for the scientists working on the Tianwen 4 mission, diamonds are just a side effect. The real treasure is something much lighter and far more valuable for the future of humanity: helium-3. While the moon has been the focus of the helium-3 race for years, ice giants like Uranus contain vast, untapped reservoirs of this rare isotope in their atmospheres. Helium-3 is considered the holy grail of clean energy, the perfect fuel for future nuclear fusion reactors that could power Earth for millennia. China's long-term interest in the outer solar system isn't about bringing resources back today, it's about strategic mapping. By sending a secondary probe to dip into the Uranus system, China is essentially performing the first deep space resource audit in history. They are identifying where the high concentrations of volatiles are located and how the intense planetary gravity could be used to facilitate future gas mining operations. But even more critical is the water. The moons of Uranus, like Ariel and Titania, show signs of recent geological activity, suggesting they might hide subsurface oceans. If Tianwen 4 can confirm that these moons have liquid water and stable surfaces, it changes the map of the solar system forever. Suddenly, Uranus isn't just a lonely destination at the edge of the dark. It becomes a potential refueling station, a cosmic gas station for missions heading even further out, toward Neptune and the Kuiper Belt.
The timing of China's journey to Uranus is not a coincidence. Space exploration at this scale requires more than just fuel. It requires a vision that spans decades. The Tianwen 4 mission is designed to reach its final destination in 2045, the 100th anniversary of the founding of the People's Republic of China. This isn't just a deadline, it's a symbolic finish line for the first phase of human expansion. While most missions are built to answer a few scientific questions, China is building a legacy that will define who leads the world in the second half of the 21st century. By 2045, the data transmitted back from the Uranus orbiter will do more than just update our textbooks. It will mark the moment the deep space gap finally closed. For over half a century, the outer solar system was an American frontier, explored by the legendary Voyager and Cassini missions. But as those aging probes fade into the interstellar dark, the silence they leave behind is being filled by a new generation of Chinese technology. If Tianwen 4 succeeds, it will prove that China has mastered the most difficult challenges in physics: long-range nuclear power, autonomous AI navigation, and communication across billions of kilometers of vacuum. This is the ultimate test of endurance. Success at Uranus means that no corner of our solar system is out of reach. It means that the ice curtain has finally been lifted, revealing a future where humanity is no longer a species of one planet, but a civilization that can operate at the very edge of the sun's influence. We are currently living in the quiet years before the storm, but in the labs of Beijing and the shipyards of Wenchang, the countdown has already begun. The race for the ice is not about who arrives first, it's about who stays, who understands, and who maps the path for those who will follow. The era of the ice giants is here, and it's colder, stranger, and more valuable than we ever dared to imagine. If you enjoyed this deep dive into the future of the solar system, don't let the algorithm decide what you see next. Take control of your curiosity. Hit that like button, share this video with someone who looks at the stars, and subscribe to Exoplanet X. We are tracking every move in the new space race, and you don't want to miss what's coming next. Thanks for watching.